So, good day guys, and welcome back to my channel. And here today we will solve a equation of differential equations given that the parameters are y and x. So, differential equation is always equatable to the movement of any objects in the nature, so, like heat, uh, vehicles, or radiation, electromagnetic waves. It can be represented as a differential equation with respect to time. So these variables could be replaced with positions and time. So first, so we will now solve and show the solution on how to uh, solve them using different techniques. So first, for the problem number one. So we have a problem that 2y squared plus 5x minus 2y plus 4 dx plus 2 plus x 2x plus 2y minus 1 dx dy equals 0. And then here we will use the integration or obtaining the integration factor, so the equation will be easier and will be solvable for us by ICE or by inspection. So how to get the integration factor? So first, we will now denote as the function related to dx as m, which is 4y squared plus 10x minus 4y plus 8, and the dy, which is n. So the function related to dy is n, ax times 2x plus 2y minus 1 equals 2x squared plus 2yx minus 1. So after getting the functions and letting them n, m, and n, so we will differentiate it depending on a certain condition. So we will get the partial derivative of m in terms of y, since the function of m is related to x. So we will differentiate it in terms of y. So it is the reverse of the variable that we need. So that is also true for dy. So we will differentiate n in terms of x later. So first, we will differentiate m by y. So this is 8y plus uh, this should be 10x. I mean 5x. This should be 5xy. So this should be 10xy. So this should be 10x minus 4, since the derivative of 8 is 0. So we can neglect that. So second is the partial derivative of n in terms of x. So that is 2x squared, that is 4x plus 2y. This is x. So minus 1. So after getting all of the getting the partial derivatives of the functions that we need, we will subtract each of them to each other. So like this. So the partial derivative of m in terms of y minus partial derivative of n in terms of x is given that 8y plus 10x minus 4 subtracted by 2y plus 4x minus 1. So here we have a function that is 6y plus 6x minus 3. So after getting all of this, so we will divide the difference of the partial derivatives by the function related to this negative sign. So this is the function. So function of n. So recall that n is equal to x. 2x plus 2y minus 1 as we have noted here earlier, like here. And then since the difference is 6y plus 6x minus 3, so divided by 2x plus 2y minus 1, this will give us the 3 over 2x 2y plus 2x minus 1 over x, 2x plus 2y minus 1, and cancel. So the integration factor that we are looking is this 3x. So this function of x will be now subjected into the another uh, formula for getting the integration factor that we will multiply to the equation. So we will now integrate p of x. So this is p of x. So e, the integral of 3 over x, that is e ln x cubed, and we can cancel this. So the integration factor we are looking is x cubed. So overall, you should note that m should be equal to the function related to dx, and n is a function related to dy. Then e of x is equal to partial derivative of m of y minus partial derivative of n in terms of x all over n. So this could be also equal to partial derivative of n in terms of x minus partial derivative of n partial in terms of y divided by m. So either way, you could get p of x. So integration factor is given by the formula e raised to integral of p of x. So whatever you get from here or here, just integrate it and raise it. So since we have v is equal to x cubed, and uh, our function is represented as 2y squared. That is our function. 2y squared. So let me just copy this. Okay. So you cannot copy the files or the equation. So we will write it 2 plus 5xy minus 2y plus 4 plus 5xy minus 2y plus 4 dx plus x 2x plus 2y minus 1 dy equals to 0. And multiplying the integration factor x cubed, we will get 4y, this is 4y squared, x cubed plus 5x, I mean 10x raised to 4y minus 4y x cubed plus 8x cubed, all multiplied by dx. So another thing is that plus x raised to 4, I mean x raised to 5 times 2 plus 2x raised to 4 y minus x raised to 4 dy. So after getting the integration factor, the equation should be an exact equation. So we can differentiate, integrate either of the functions, whether m or n. So the condition here is get the function that has more terms. So we will differentiate, I integrate this function related to the x. So integral of 4y squared x cubed plus 10x raised to 4y is 4y x cubed plus 8x cubed dx. So we will let that y is equal to a constant. So here we will now differentiate this. So this is y squared x raised to 4 plus 2 to x raised to 5y minus y x raised to 4, and this is 2x raised to 4 is equal to c. And that will be our answer for number 1. Okay, so take a time to ponder about this. So that is how you get the solution using integration factor in differential equation. So the next thing that we will note is that in number 2, there is another method that we could apply. So y is equal to, y times 3xy, so dx minus x dy is equal to 0. So first, I will distribute the variable y. So this is 2y minus 3xy squared dx minus x dy equal to 0. So the thing is, I will combine those uh, terms that are homogeneous to each other, which means that the equations are in nature are almost the same in their exponent. So these two terms are homogeneous to each other because they have a exponent that is equal to 1. So this exponent has equal to 3, so 1 plus 3 is 2. So I will neglect this first, but I will get later I will later get back on that term. So 2y dx minus x dy minus 3xy squared is equal to dx is equal to 0. So how can I solve this without getting the integration factor that I need? So first I will note that here in this part, the differentiated variable is x, and there is a constant of 2. So how can I get a constant of 2 using differential of x? So there should be an x squared here missing, so 2 dx. So 2x dx here in my term. So I need to multiply here an x in this equation to satisfy this term. So okay, so the equation will be like 2xy dx minus x squared dy. So don't forget to multiply an additional x here since this is an equation. So you should also multiply x here to solidify, to maintain the equality of the problem. And another, so since we have established the relationship here, I could see that this equation is mostly related to the derivative of a quotient rule, which is represented as differentiating u over v is equal to v du minus u dv minus v squared. So some students say that it is uh, low d high, high d low, low low. So it does mean it just means that low is just the denominator, high is just the numerator. That is what I was trying to do. So since I will relate this equation to this equation, so VDU is just uh, so V, what is V first? So this is V. For me, I see that V is here, this Y. And that du is just dx. And our, so dx. Okay, so dx and 2x. And here that my u is this, I mean this one. And my dv is this one. So if that is what I want, so I will let that u is equal to x squared and iv is equal to x, I to y. So using the formula u, so x squared over y, I will get, so y times the derivative of 2x, I mean x squared minus x squared, the derivative of y, all over y squared. And that will give us a y times 2x dx minus x squared dy all over y squared. So the only variable that I need in this equation is the missing term of y squared here in the bottom or in the denominator. So I will put a y squared here as well as a y squared here. So I will cancel this out since they are of the same. So this term will be 2xy dx minus x squared dy all over y squared. And this term will be 3x squared dx equals to 0. Remember that we have derived the formula for this, and that is equal to d of x squared over y, as we have mentioned earlier. 3x squared dx is equal to 0, since these two are the same. As you can see, they are of the same nature. So integrating this both, since we can now, since this has the same variable and this will cancel out, so integrating also this. So the integral of derivative of x squared over y will just cancel this integral and derivative, so this will just simplify x squared minus y. And the integral of 3x squared is just x cubed. And the integral of 0 is c. So multiplying x squared by I mean y, so we will have now denominator here, x cubed y is equal to cy, and that will be our answer. So hope you enjoy, guys, and you learn something new. Sorry for my stuttering and for my bad solution, but I hope I have explained well. So thank you. Please leave a like and subscribe to my YouTube channel. I will leave the number 3 for the viewers too. So that's it. Thank you.